So if we're going to solve this problem, this is the first constructive response on the second subtest for the CSET single subject in mathematics. All right, so in this question, it says use the diagram below to complete the exercise that follows. And then it wants us to use the techniques of coordinate geometry to prove the segment joining the midpoints of two sides of a triangle is parallel to the third side of the triangle and its length. Okay, so there are two things that this question is asking us to prove, and they're asking us to do it in a specific way using coordinate geometry. Okay, so it does give us that the segment joining the two lines is the midpoints. So that'll be crucial for our construction of this problem. Okay, so I'm going to do it in general, and then we'll arrive at some exciting conclusions. Okay, so our points here, we're gonna assign the coordinates since that's what it's asking us to do first. So this first one, um, by construction, it looks like the x and y values of the r point r are going to be our origin. So we're going to call that point, the x and y coordinates there, 0, 0. And likewise, the point T is along the same line as R. And so I can call the points or the coordinates for the point T, I'm going to call it little t1 and 0 since the y values on those two are the same. Okay. Uh, point U and V, point U and V are right now we're just going to call V1 and V2 for the two coordinates of that one, and likewise U1 and U2. So part of our task will be to figure out what those are. And then last but not least, our point S is S1 and S2. So those are all the coordinates then that we have. Okay. So now we need to use the result here, the midpoints, to determine what the corresponding coordinates are in terms of the given information. Okay, so recall that the midpoint is given by the relationship x1 plus x2 over 2 and y1 plus y2 over 2. Okay, so the midpoint, I guess one way to think about it is uh, kind of like in the same sense that you would average two numbers together, right? So if you had two numbers, let's say 7 and 9, right? If you wanted to know the average of those two, right, you would say, well, that 7 plus 9 divided by 2, where you would add them up and then divide by the numbers there, right? So this would be what, 16 divided by 2, which is 8, which is exactly what you would expect because it's 7, 8, 9. What number's right in the middle of those two, right? That's the missing number is 8. So you can see it's exactly the same idea. You're just doing it for the two components, okay? So to find the midpoint for U1, the point U1, okay, the x coordinate is going to be the average of these two coordinates. So it's going to be S1 plus 0 divided by 2. And likewise, U2 is going to be the y coordinate. So it's going to be S2 plus 0 divided by 2, since we're referring back to here the origin. Okay, so U1 and U2 in terms of the other geometries is very simply just going to be so right here, S1 over 2 and S2 over 2. Okay, so that's the two coordinates here. And now we can do the same thing for V1 and V2. So V1 is going to be the average of the 2 points S and T. So it's going to be S1 plus T1 over 2, and V2 is going to equal what, S2 plus 0 over 2. Okay, so that tells me then that I guess this would be U, and V is going to equal S1 plus T1 over 2, and just S2 over 2. Okay. Okay, so there's the coordinates for this point. Okay. So we have these coordinates here, and we have these coordinates there. Okay. All right. So the next part is, now that we have all of the geometry kind of at least expressed in terms of some of the coordinates here. Let's tackle the parallel. Okay, so there are many ways to show two lines that are parallel. The two most common ways are show uh, like something like alternate interior angles are congruent, or show M1 equals M2. Uh, in other words, show that the slopes are parallel for the two lines. So just kind of like broadcasting that. So that's one of the first things that we have to show. And then the second thing we have to show is that I'm going to call it L1, which is the um, length of U to V. Um, and I'm going to define L2 equal to RT, the length. Okay. Of this segment. I should have written that better, but you get the idea. So that's the length of this segment RT. So um, I want to show that L1 divided by L2 is equal to 1/2. Since it said show that the third side of the triangle is half of its length. So show that this one is half of this, or show that this one is half of that length there. Okay. All right. So those are the two things that I want to show. Okay. So want to show is my shorthand notation for what I want to show. Okay. So I'm going to take the opportunity here to use the slopes. All right, I'm going to find the slopes. Since I'm given 2 points here and 2 points here. Okay, so let's begin the proof. So um, U is written as has the points S1, 2, and S2 over 2. And V has the points uh, S1 plus T1 over 2 and S2 over 2. Okay, so slope is given by MUV. Okay, so this is the slope between those 2 points is given by S2 over 2 minus S2 over 2. This is the difference in the y coordinates divided by S1 plus T1 over 2 minus S1 over 2. Okay, I don't need to worry about subtracting these per se at this moment because I notice that I have S2 minus S2, and since these are not equal to 0, in other words, T1 is still some value, uh, so you should, I guess I should note that S1 plus T1 over 2 minus S1 over 2 is not equal to 0. Uh, I'm assuming that T1 is different than 0 so that these two are not the same value. In other words, it's not a vertical line. That then I have a non-zero value divided by a zero value. So this is 0 over some number. And if you wanted to, you could actually multiply top and bottom here by 2 since they're all divisible by 2 to cancel out the common factor or the common divisor. But this is equal to 0. So the slope connecting the points U and V, not that you can see it there, but the points U and V, much like an image shows that that slope is equal to 0. Okay, so um, however, note that the point R is equal to 0, 0, and T is equal to T1, 0. Okay, so that's the coordinates there, which implies that the slope MRT is equal to 0 minus 0 over T1 minus 0, which is equal to 0 since T1 is not equal to 0. Okay, so uh, MUV is equal to MRT. Okay, but uh, the y intercept of uv of line uv, oh, line uv is not the same as the 0 y-intercept of line RT. So line, so UV is parallel to RT. And I'm using the double arrows here to indicate that or to imply that what I'm referring to is the line that goes through the points. Okay. All right, so we have the first part proven. We wanted to show the two lines are parallel. Now we want to show that the distance, the ratio of the distances is equal to 1/2. So the second part, okay, I'm going to call D1 equal to the distance of um, the magnitude of UV. This is the distance UV, okay, which is going to equal the square root of, what do we have here? It's x2 minus x1, so we have x2, v is s1 plus p1 over 2 minus s1 over 2 squared plus the, well, it is 0, but it's s2 over 2 minus s2 over 2 squared. So this is 0. The s1s cancel out, and you're left with t1 over 2 squared square root. So this is just t1 over 2. Okay. So that's the distance of this d1 here. And then d2 is the distance of our t, which is equal to the square root of uh, t1 minus 0 squared plus 0 minus 0 squared, which is equal to, of course, t1, because t1 is squared, or t1 is, okay. All right, so the ratio then, putting these together, d1 divided by d2 is equal to t1 divided by 2 divided by t1. Okay, so the t1s cancel, and you're left with the ratio of d1 to d2, which is equal to 1/2, which is what we wanted to show. Okay, all right, I hope that was helpful, and I'll see you on the next video.